Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Dislocated Digits by Will Power, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. We have disjoint sets, where cells that appear in the same position in the 9 different boxes cannot have the same digit. So for example, say there was a 6 in this position in this box here. That means in the upper left-hand corner of every other box, you could also not have a 6 because that's what disjoint sets are, right? So you could not have a 6 here. Obviously, you would not be able to have a 6 in the row and the column that it's in, but you also cannot have a 6 in any of the other cells that are in the same position for other boxes, right? So that's basically upper left corner, upper central position, upper right corner, left central position, the center cell, right central, etc., right? So that's an example of how disjoint sets works. We also have crop key pairs, where digits with a black dot between them are in a ratio of 2 to 1. Not all possible dots are shown. So for example, if this were, say, a 2, this would have to be 1 or 4 to maintain the 1 to 2 ratio between them. And that's an example of how crop key pairs work. And finally, we have XV pairs, where digits with an X between them sum to 10. Not all possible X's are given. I would prefer adding not all possible dots are necessarily shown, right? It could be that there are no more, but there also could be some, right? That's just preferential wording. I think it's fine either way. So for example, if this were, say, a 3, this would have to be a 7 because there's an X in between them and they must add up to 10. So that's an example of how XV pairs work. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay. So, the ones that stick out to me, first things first, are the ones that have that are in the cells that are in a 1 to 2 ratio with 2 other unique digits. The only possible digits that can fill that role are 2, which could be in a 1 to 2 ratio with 1 and 4, or 4, which could be in a 1 to 2 ratio with 2 and 8. So anytime you have 3 in a row, or sorry, anytime you have a cell with 2 unique which is in a 1 to 2 ratio with 2 unique digits, it has to be a 2 or 4. So this must be 2 or 4. That's in a 1 to 2 ratio with 1 and 8 here, 1 and 8 here. This is 2 or 4, 2 or 4, 1 and 8. This is also 2 or 4, but we don't know what this is. It could be 1 out of 1, 2, 4, or 8. We're not sure. But we do know that this has to contain a 2 and a 4 in some scenario, right? If it's 2, it's in a 1 to 2 ratio with 1 and 4, so obviously it contains a 4 in that set. If it's a 4, it's in a 1 to 2 ratio with 2 and 8, so it must contain a 2 in that set. So this cannot contain 2 or 4 as a 1 to 2 ratio, therefore it must be 3 and 6. Anytime you have 3 sets of those scenarios in a row or a column, any black crop key dots, I guess I should say, then you know the remaining digits in that box, row, or column must be 5, 7, and 9, right? Because has to be some combination of 1, 2, 4, 6, 1, 2, 2, 4, 3, 6, or 4, 8. Well, what digits are not represented by that? It's 5, 7, and 9. So in this left central box, this must be 5, 7, and 9. Let's maybe highlight them. Just basically, we're going to make them red. In column 1, this can't be, this is not next to a black crop dot, and this is not. In this lower right-hand box, this is not a next to a black crop dot, and neither is this. In the central box, this is not next to a black crop dot, so therefore these are all 5, 7, and 9. So, what does that mean? That means these 10 cells, these cells that add up to 10, cannot contain, oh, this has to be 3 and 6 because of the 3, 6, the 1, 2, 4, 8 quadruplet in the box. This cannot contain 9 or 7. So there's no 1, 9, and there's no 3, 7. Therefore, this must be 2, 8, and 4, 6 adding up to 10. Well, that means the rest of the row cannot contain 2, 8, or 4, 6. So this can't be 2, 8, or 4, 6. So it's 3, which makes this 6. This has to be 1, because that's the only digit remaining. Because remember, these are 5, 7, and 9 here. So 1 is in a 1 to 2 ratio only with 2. So that's 2 and 8. This can't be 2 and 8 here. So this is 4 and 6. 4 is going to be in a 1 to 2 ratio either with 2 or 8, and 6 is in a 1 to 2 ratio with 3. But if 4 were in a 1 to 2 ratio here with 2, the only digits remaining that could be next to a black copy dot would be 1 and 8, because we have 3 here. Excuse me. And 1 and 8 is not in a 1 to 2 ratio. So therefore, this cannot be 2. This has to be 8 with 3. Therefore, this is 1 and 2 here. This 3-8 pair eliminates 3 and 8 in the rest of the row, so this can't be 8. This is 1, which is in a 1 to 2 ratio with 2, which is in a 1 to 2 ratio with 4, which is in a 1 to 2 ratio with 8. 2 eliminates 2 here, so that's 1 and 2. 4 here eliminates 4 here, so this is 2, which can only be in a 1 to 2 ratio with 1 and 4, and this can't be 4, so this is 1, and this is 4. Okay. What else do we have? These are 5, 7, 9. We are guaranteed a 4 somewhere here. We're not sure where. So this has to be 1, 2, or 4, 8. This is 4, 8, or 3, 6. These add up to 10, and you can't have a 2 or 4 here, so it must be either 1, 9, or 3, 7. And this can't be 1 because of 1 in the column, so this can't be 9. This can't be 2 and 1 in a 1 to 2 ratio, so this is either 3, 6, or 4 and 8, with this being 4 and that being 8. These are all next to black crop key dots. So, and we know this is 1 or 3 with 7 or 9. 7 or 9 cannot be next to a black crop key dot, but 1 and 3 can be. So one of these is 7 or 9. These are all next to black crop key dots. So these have to be the remaining digits, which cannot be next to black crop key dots, right? So it's 5, 7, and 9. So that's actually pretty important information there. What are the possibilities for this cell here? It's quite a bit. It could be 1, 2, 1, 3, 6, or 8. Oops. One is in a 1 to 2 ratio with 2. 3 is in a 1 to 2 ratio with 6. 6 is in a 1 to 2 ratio with 3. And 8 is in a 1 to 2 ratio with 4. Now we're probably going to be using disjoint sets. Yes. So this is an 8 in the upper left-hand position. in a box. So this cannot be 8, which makes this a 1. 1's in a 1 to 2 ratio with 2, which is in a 1 to 2 ratio with 4, which is in a 1 to 2 ratio with 8. This 1-2 pair eliminates 1 and 2 in the rest of the column, so this can't be 1 or 2. We have a 6 here, so this cannot be 6 in that position, so therefore this can't be 3. Where is 1 in this upper left-hand box? It can't be here, it can't be here, and it can't be here. And it's obviously not here because it's not 5, 7, or 9. So it has to be here. Where is 1 in row 2? Cannot be any of these because these are 3, 6, and 8. So this must be 1 here, and this must be 9 here. So this is a red spot here. Where is 1 in column 7? Can't be here because of 1 in the box. Can't be here because it must be 5, 7, or 9. So it has to be one of these two. So it must be in a 1 to 2 ratio with 2. And 2 cannot be here. So this is 1, which makes this 2. We have 8 ones. We know where the last one has to be. It has to be there. What about 2s? 2, similarly, cannot be here or here because of 2's in the column. Can't be here because of 2 in the row, and this is a 5, 7, or 9 because of what's remaining in column 1, so 2 has to be here. Where is a 2 in row 1? Cannot be here because of 2 in the boxes. Can't be here because of 2 is in the column, so it must be here. And we have 8 2's now. We know where the last 2 has to be. It has to be here. 3's. We don't have very many 3's. Okay, let's go to 4's. This 4 eliminates 4 here, so this is 6 and 3. Therefore, this can't be 6. This is 4 and 8. Therefore, this can't be 4 and 8. This is 6 and 3, which eliminates 6 and 3 here. So this is 8, and this is 4. 3 eliminates 3 here, so it's 6 and 3. Actually, that gave us a lot of information. This cannot be 4 and 8 because of the 4 in the row. So this must be a 3, 6 pair. And 3 cannot be in the central cell because of the 3 here by disjoint sets. So this must be 6 here and 3 here. This is 4 and 8. 4 cannot be in the upper right-hand corner because of disjoint sets. So this must be 8 and 4 here. So let's continue with the 3's, see if we have any more information. 3 can't be in the upper right-hand corner because of this 3, so this can't be 3 here and here. So 3 can't be here because of 3's in the box. 3 can't be here because of disjoint set for that, and 3 can't be here because of 3 in the row. So this is 3 here. 3 cannot be, well, Where's 3 in column 5? Can't be here because of 3 in the column. Can't be here because of 3 in the row, so this must be 3 here. And here we don't have enough information. Okay, so 4's. 4 in column 6 cannot be here because of 4 in the column. Can't be here because of 4's in the row, so it must be here. Where can 4 be in row 5? Can't be here because of 4's in the box. Can't be here because of disjoint set with this 4 here. Can't be here because of 4 in the column, so this is 4 here. We have 8 4's. We know where the last 4 has to be. It has to be here. Okay. 6's. In row 1, 6's can't be here because of 6 in the box and can't be here because of 6 in the column, so this is 6. In row 6, 6 can't be here because 6 in the box and can't be here because of 6 in the column, so 6 is here. In column 3, 6's can't be here because of 6 in the columns, or sorry, 6 in the boxes and can't be here because of 6 in the rows, so it must be here. So that's 6. And we have 8 6's, so we know where the last 6 has to be. It has to be here. 8's. 8 in, let's see, we have, okay, 8 in column 8. 8 cannot be here because of 8 in the boxes. 8 can't be here because of disjoint sets and 8 there. And this is filled in, so 8 has to be here. Which means in row 3, 8 cannot be here or here because of 8 in the boxes, can't be here because of 8 in the column, so it must be here. That gives us 8 eighths. We know where the last 8 has to be. It has to be here. Finally, we have 3s. Where can 3 be in row 3? Can't be here because the 3's in the boxes. Can't be here because the 3 in the column, so 3 must be here. And we have 8 3s, so we know where the last 3 has to be. It has to be here. 3 adds up with 7 to add up to 10. This is then 5, because it's the remaining digit in the box. This leaves this as 7, because that's the remaining digit in the row. Also in column 9, this has to be 5. Okay. So this is... The remaining digits are the 5, 7, 9, right? So let's just, I guess, fill them out. We can remove the reds, I guess, for now, because we've done all of the... This has to be 5 or 9 here. So 5 and 9. This is 5 or 9. We have 5, 7, 9 here, 5, 7, 9 here. I guess we should just fill everything else out with 5, 7, 9s, right? And then we'll remove possibilities. Okay. This can't be 5. This can't be 5. This can't be 5. This can't be 5 here. No 7 here, no 7 here, because of, these are 7s and 5s in the columns and rows. Okay. Where should we look now? Let's look at disjoint sets. We only have a certain amount of 5s and 7s, though. So we only have 2 5s. So this cannot be 5 here because of a disjoint set with that. So this is 9 here, which makes this 5. 9 eliminates 9 here, so that's 5. And obviously these can't be 5 anymore. That can't be 5. This can't be 5. What about 7s? 7 cannot be in the middle box because we have a 7 now in the middle box there. So we have a 5-9 pair in row 5 now, which eliminates 5 and 9 in the rest of the row. This can't be 9. This is 7, which makes that not 7, so it's 9, which makes this not 9, so that's 7. That eliminates 7 here. We have a 5-9 pair in row 6, which eliminates 5 and 9 in the rest of that row. So this can't be 9. This is 7, which eliminates 7 here, so that's 9, which eliminates 9 here, so it's 5, which eliminates 5 here, so it's 9. This can't be 7 or 9, it's 5. This can't be 5 or 9, it's 7. 7 eliminates 7 here, so it's 9, which eliminates 9 here, so it's 7 and 9, which eliminates 9 here, so it's 5. This can't be 5 or 9, it's 7. No 5 or 7, it's 9. This can't be 5 or 9, it's 7. This can't be 7 or 9, it's 5. 5 eliminates 5 here, so it's 9, which eliminates 9 here. So that's 5. And that's an example of how you solve it. Yeah, I mean, fairly straightforward. Basically, you just had to notice that there are certain situations where 5, 7, and 9 had to be in the in certain spaces. And that limits things a lot about where you can go, right? So it limited this, obviously, here, and then these. And that was essentially the break-in. Yeah, a lot of this was just black crop key dots, and then everything filled out from just basically disjoint sets. And then that was it. I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.